this is an optimization excellence question, and you will see the difference between this optimization question and the merit question of optimization. Usually the merit question of optimization is the equation is being given to you, or a straightforward equation you can solve, you can create. It does not involve a third variable, but in excellence is always involve a third variable, and to differentiate it most of the time it actually involve product rule or quotient rule. Okay, so it's the volume of a cylinder, so it's always an optimization question. It's a merit or excellence question, doesn't really matter. That what matter is you read, the first thing is read what you're finding maximum of. So in this case here we are finding a maximum of a volume of a cylinder, so I would write the volume of a cylinder equation. Sorry, that's not 1/3, that's a cone. So this volume of cylinder equation, it's pi r square h. Okay, so you need the h value, which is the height of the cylinder. That's the h value, and that should be the r. Okay, whenever you have a circular shapes, means cylinder, cone, sphere, so it's all these shapes, you will always think of either there's only three type of equations you can create to link the two variables. Why I'm saying link the two variables, because if you look into here, the volume has radius and height, and you cannot differentiate with two variables. So therefore, you will have to find a second equation to link the r and h together, so you can resubstitute into the volume equation. So now, because the shape we have is a cylinder, and as I said, cylinder, cone or sphere, those three circular shapes, you will always have to think of one of those three will be useful for you, either trig ratio or Pythagoras, or trig ratio or Pythagoras or similar triangles. In this case here, we don't have any idea about the angle, so trig ratio is being excluded. So it's either similar triangle or a Pythagoras, and we will have to look. I don't have a triangle, but anyway, I'll use the blue and see what can we do. So in here it says the other piece of information is being given to us is inside a sphere is a radius of 20. So from the center here to the bottom is 20. Okay, 20, not 26, 20. All right, and from this one, that's the center, to any side of the sphere is 20. Can you see how that works? So therefore I can create this triangle here. So this triangle here says whatever this x is, okay, so we need to find that triangle, the blue one. So I'm just going to take this one off so you can see which triangle I'm talking. So that blue one is a triangle in here. So in that triangle, this side here, just drawing the triangle over here so you can see which one I'm talking. So this is r, and this is here is half of h, and that would be 20. So I have a right angle triangle with one side is given, so definitely I would use Pythagoras in this case, that link the h and the r. So equation that links an h and the r. So using Pythagoras is 20 square equal r square plus h over 2 all square. So that will give me 400. So r square, it gives me h square over 4, and this one will give, take it to the other side. So I took this one to the other side, so it becomes 400 minus h squared over 4. Okay, so that's r squared. Why did I choose r squared? Because it's a direct substitution in here. So now I will substitute it back in here. 400 minus h squared over 4 times h. Now I can expand, or you can use product rule, or you can expand. So I'll expand, it's easier. Now I can differentiate nicely. The pi stays because it's a constant, and this one 400 minus 3h squared over 4. And because I'm finding maximum minimum, so I'm going to make this is equal to 0 and find the value of h. So 400 equal 3h squared over 4. So h is equal square root of, that's 1600 over 3. Find it in the calculator. Got 23.1, and it's centimeter because we're dealing with centimeters in here. And once I know the h, I can find the volume, which is, I can substitute directly in here, or I could do the r in here and then back, so it's up to you. I'll substitute directly in here. So it's pi and 400 minus 23.1 over 4, that's square times 23.1. Get it in the calculator, and the answer is 19,300 centimeter cube. So that's the optimization question, and it's an excellent one, because you need to get the second equation to connect the two variables. That's why it's an excellence.